Let us consider one more example based on the composite functions. So we have, if u is equal to x square plus y square and x is equal to e raised to t cos t, y is equal to e raised to t sin t, then we have to find out what is du by dt. So here we need to understand what is the variable t. So here if we see, u is a function of x and y, x is a function of t and y is a function of t. So we need to understand here how to find out the derivative of u with respect to t. So if we see t and u, then u is a function of only variable t. So that's why the derivative will be total derivative. So here the derivative of u with respect to x will be the partial derivative, derivative of u with respect to y will be the partial derivative, derivative of y with respect to t will be the total derivative, and derivative of x with respect to t will be the total derivative. So if we want to find out the derivative of u with respect to t, then we have du by dt is equal to dabba u by dabba x dx by dt for this branch, and then for this branch dabba u by dabba y into dy by dt. So here if we see, we have to find out these four derivatives. So the derivative of y with respect to t, the derivative of y x with respect to t, the derivative of u with respect to x, and the derivative of u with respect to y. So let us calculate these four derivatives and then calculate the required derivative. So we will consider the solution. Let u is equal to x square plus y square, and what we have is x is equal to e raised to t cos t and y is equal to e raised to t into sin t. So let us differentiate this x and y with respect to t. So we have dx by dt is equal to, so u into v rule we have to consider, it is e raised to t, the derivative of e raised to t is e raised to t and cos t remains as it is, plus the derivative of cos t, so e raised to t remains as it is, and the derivative of cos t is minus sin t. So we get dx by dt is equal to, e raised to t is common and we have cos t minus sin t. Now the derivative of y with respect to t, so we have dy by dt is equal to e raised to t, the derivative of e raised to t is e raised to t and sin t remains as it is, plus e raised to t remains as it is, and the derivative of sin t is going to be cos of t. So we have dy by dt is equal to, e raised to t is a common, so we have sin t plus cos of t. So this way we got the derivative of x with respect to t and the derivative of y with respect to t. Now we want to find out the derivative of u with respect to x and with respect to y. So let us find the derivative of u with respect to x and with respect to y. So we have differentiating u with respect to x, that is dabba u by dabba x is equal to 2x, and dabba u by dabba y is equal to 2y. So we got the derivative of u with respect to x and with respect to y, and now we are able to find the derivative of u with respect to t. So consider the derivative of u du by dt. So this is dabba u by dabba x and dx by dt plus dabba u by dabba y and dy by dt. So put up the values of all four derivatives we have calculated. So it is going to be 2x into e raised to t, and this is going to be cos t minus sin t, plus we have 2y and the derivative of y, so it is going to be e raised to t, we have sin t and plus cos of t. Now we put the value of x and y, then we have, this is twice, so x is e raised to t into cos t into e raised to t, and this is cos t minus sin t, plus we have 2 e raised to t into sin t, this is e raised to t and this is sin t plus cos t. So let us simplify this. So we have 2 is common, then we have this e raised to t into e raised to t, so we have e raised to 2t common, and then for this term we have cos square t minus sin t into cos t. For this term we have plus sin square t and plus this is sin t into cos t. Now we can see that here we have the minus sin t cos t, here we have the plus sin t cos t. So these two terms will get cancelled and hence we get twice e raised to 2t and we will be having cos square t plus sin square t. But what we know is cos square theta plus sin square theta is equal to 1. So this way we got twice e raised to 2t into 1 and hence we got du by dt is equal to twice e raised to 2t. So this way we are able to prove the claim using partial derivatives.